Hello, dear friends, and welcome. I'm so happy to have you here. As we begin, I'd love it if you could share in the comments where you're joining from and the time of day it is for you right now. It's always wonderful to witness people tuning in from across the world. Thank you as well to those who have already subscribed and shared their support by liking the videos. It helps more than you know. And please don't hesitate to leave your ideas or requests for future videos. Let's get started. Chapter 1. Understanding supervolcanoes and their impact. Supervolcanoes are remarkable geological phenomena, distinct from their more familiar volcanic counterparts. To understand what sets them apart, one must first consider their sheer scale. A supervolcano is defined by its ability to produce an eruption with a volume of over 1,000 cubic kilometers of material. This is vastly larger than typical volcanic eruptions, which might release only a fraction of that amount. Imagine standing at the edge of a caldera, a massive crater formed by the collapse of land following a supereruption, and gazing into the immense void. This extraordinary formation speaks to the power and depth of the geological forces at play. The characteristics of supervolcanoes extend beyond their size. They often reside beneath large volcanic systems where magma pools accumulate over time. The pressure from this molten rock builds, creating vast reservoirs that can remain dormant for centuries or even millennia. When a supervolcano erupts, it can unleash a catastrophic explosion, spewing ash and gases high into the atmosphere, transforming landscapes and impacting climate on a global scale. The aftermath of such eruptions can lead to widespread destruction and long-term environmental change. Looking back through history, we can find examples of supervolcanic eruptions that have shaped our planet and its inhabitants. One of the most well-known is the eruption of Yellowstone, which occurred approximately 600,000 years ago. This event released an astonishing amount of ash and debris, covering much of what is now the United States. The geological record shows that the eruption was so powerful that it altered the landscape dramatically, creating the Yellowstone caldera we know today. Another significant historical example is the eruption of Toba in Indonesia, which took place around 74,000 years ago. This eruption is believed to have had a profound impact on the Earth's climate, likely causing a volcanic winter that led to a dramatic reduction in global temperatures. It has been suggested that this event may have even reduced the human population significantly, leading to a genetic bottleneck. This illustrates the interconnectedness of geological events and their potential consequences on life. The geological processes behind supervolcano formation are complex and fascinating. They typically begin with the accumulation of magma beneath the Earth's crust, often in a hot spot, where heat from the mantle melts rock and generates molten material. Over time, this magma can migrate towards the surface, building pressure within the crust. The process can be likened to a kettle boiling on a stove. As the heat increases, steam builds up until it can no longer be contained, resulting in an explosive release. This buildup can occur over thousands of years, making it difficult to predict when a supervolcano might erupt. The crust above the magma reservoir can become unstable, leading to the formation of large cracks and fissures. When pressure finally exceeds the strength of the surrounding rock, the supervolcano erupts, releasing magma, ash, and gases with incredible force. In contrast to regular volcanoes, which tend to have more frequent but smaller eruptions, supervolcanoes are characterized by their infrequent, yet immensely powerful eruptions. Regular volcanoes, such as Mount St. Helens or Mount Fuji, often erupt with a variety of behaviors, from gentle lava flows to explosive ash clouds. They typically release smaller volumes of material and can show signs of activity that allow scientists to predict eruptions more reliably. Supervolcanoes, however, often lie dormant for extended periods, making them less predictable and potentially more dangerous. Their eruptions can lead to widespread ash fall, pyroclastic flows, and even tsunamis if located near water bodies. The effects of a supervolcanic eruption can ripple across continents, impacting agriculture and ecosystems. Imagine a world where the sky is darkened by ash, sunlight struggling to penetrate the thick clouds. This scenario highlights the potential for supervolcano eruptions to disrupt weather patterns, leading to crop failures and food shortages. The global climate could shift dramatically, as seen after the Toba eruption, which may have caused temperatures to plummet for years. Scientists continue to study the potential impacts of future supervolcano eruptions, recognizing the importance of understanding these colossal forces of nature. As we reflect on the implications of supervolcanoes, one cannot help but ponder their impact on human civilization. The history of our species is intertwined with the Earth's geological processes. In the face of such powerful natural events, resilience and adaptation have been key to survival. Throughout history, humans have faced challenges posed by the environment, and the study of supervolcanoes serves as a reminder of our ongoing relationship with the planet. In understanding supervolcanoes, we also gain insight into the Earth's inner workings. These colossal systems remind us of the dynamic nature of our planet, constantly changing and evolving. As scientists continue to explore, they build upon the knowledge of past eruptions to better predict future events. This ongoing pursuit of understanding is essential, for with knowledge comes the power to prepare and adapt. Consider the words of the renowned geologist John McPhee, who once said, "The rocks do not lie." This statement encapsulates the essence of geological study, where the past is written in the layers of rock, revealing the history of our planet. By studying supervolcanoes, we are not only uncovering the secrets of past eruptions, but also preparing for the future. Supervolcanoes, in their grandeur and complexity, invite us to marvel at the forces shaping our world. They are a testament to the power of nature, capable of altering landscapes and influencing climate on a global scale. As we delve deeper into their mysteries, we continue to foster a sense of awe and respect for the Earth beneath our feet. The mechanisms that lead to the formation of supervolcanoes are not only fascinating, but also illustrate the intricate dance of geological forces beneath our feet. At their core, these processes are driven by the heat emanating from the Earth's mantle. Picture the planet's inner layer, a realm of molten rock and immense pressure, where temperatures soar far beyond what we can imagine. This heat creates convection currents, stirring the mantle and causing magma to rise towards the crust, accumulating in large chambers. As magma pools in these chambers, it does not just sit idly. The gases dissolved in the magma, primarily water vapor, carbon dioxide, and sulfur dioxide, begin to expand under the decreasing pressure found closer to the surface. This is similar to opening a shaken soda can, where the built-up pressure releases with a forceful hiss. When the pressure reaches a critical point, it can lead to an explosive eruption, displacing vast amounts of rock and generating a caldera. The formation of these calderas is a remarkable testament to the Earth's power. When a supervolcano erupts, it can create depressions that are often several kilometers wide. The Yellowstone caldera, for instance, is a profound reminder of such events, a vast landscape that has been shaped by the fury of nature. The geological history etched into the walls of these calderas tells tales of eruptions that reshaped ecosystems and altered the course of rivers and valleys. In contrast to the familiar cone-shaped volcanoes that dot the Earth, supervolcanoes often manifest as broad, gently sloping structures with expansive calderas at their summits. This unique profile stems from the nature of their eruptions, which tend to eject massive quantities of ash and pumice rather than the more viscous lava flows typical of smaller volcanoes. Imagine the landscape blanketed in a thick layer of ash, a reminder of the powerful forces that once roared to life. Throughout history, humanity has experienced the far-reaching consequences of supervolcanic activity. The eruption of the Campi Flegrei supervolcano in Italy, for example, is believed to have occurred around 39,000 years ago. This event not only devastated local habitats, but may have also influenced climate patterns across Europe. The ash fallout from such eruptions can lead to agricultural collapse, forcing communities to adapt and migrate, showcasing the intricate relationship between humans and the Earth. Furthermore, the environmental impact of supervolcano eruptions extends beyond immediate destruction. The vast quantities of ash and gases released into the atmosphere have the potential to alter climate patterns for years. The Toba eruption's chilling effects are often quoted as a pivotal moment in human history, suggesting that it may have pushed our ancestors to the brink of extinction. In reflecting on this, one might wonder, how does a single eruption ripple through the fabric of life? The effects of these eruptions extend even to the present day. Scientists study the geological layers left behind, which serve as historical records of past volcanic activity. These records help us understand the patterns and frequencies of eruptions, providing insight into their potential future impacts. As the Earth continues to change, the knowledge gained from these studies equips us with the tools to brace for what may come. Consider the work of scientists like Bill McGuire, who has dedicated his career to understanding the implications of supervolcanoes. He has remarked, "We have to understand how to live with the threat posed by these monsters." This perspective invites a sense of urgency in the study of supervolcanoes, emphasizing the need for preparedness in the face of their potential wrath. While the thought of supervolcanic eruptions may evoke fear, it is essential to channel that energy into learning and understanding. Imagine standing on the edge of an ancient caldera, feeling the weight of history beneath your feet. The great forces of nature have the ability to create as well as destroy. They shape the world we inhabit, influencing everything from ecosystems to climate. In contemplating the future, one must acknowledge the uncertainty that surrounds supervolcanoes. Their lengthy dormancy can lead to complacency, yet scientists are keenly aware of the need for vigilance. Monitoring systems have been established around known supervolcanoes, tracking seismic activity, ground deformation, and gas emissions. These systems serve as an early warning, a way to listen to the subtle signs of awakening beneath the surface. Understanding the geological intricacies of supervolcanoes also sheds light on the broader context of volcanic activity as a whole. By comparing the behaviors and characteristics of supervolcanoes with those of regular volcanoes, scientists can develop predictive models that may one day provide insights into the timing and magnitude of potential eruptions. This research is not merely academic. It holds profound implications for communities and ecosystems that could be affected by such events. As we reflect on the tales woven into the geological fabric of our planet, we are reminded of the delicate balance that exists between humanity and nature. Supervolcanoes serve as a powerful metaphor for the unpredictable forces of the Earth. They remind us of our vulnerability, yet they also inspire us to seek knowledge and cultivate resilience. With every discovery made beneath the surface, we are drawn closer to understanding the profound mysteries that govern our planet's geological processes. Each layer of rock, each shift in the Earth's crust, tells a story of transformation and renewal. These stories beckon us to listen, to learn, and to prepare for the future. They challenge us to embrace the awe-inspiring complexity of our world as we stand on the threshold of nature's most potent forces. Chapter 2: The Science of Eruptions: How Supervolcanoes Erupt. As we explore the intricate mechanisms of supervolcanic eruptions, we begin to peel back the layers of the Earth's crust, revealing the complex interactions that lead to these monumental events. At the heart of a supervolcano lies a vast reservoir of magma, a molten rock that is rich in gases and heat. Over time, this magma accumulates beneath the surface, creating immense pressure as the gases dissolve within, much like carbon dioxide in a shaken soda bottle. When the pressure reaches a critical point, the results can be astonishing and devastating. The mechanisms of eruption can be understood through various stages. Initially, the magma rises through cracks and fissures in the Earth's crust, driven by buoyancy and pressure. It can either accumulate in magma chambers or escape through volcanic vents. If the magma chamber becomes too full, the pressure can lead to fracturing of surrounding rock, allowing magma and gases to escape explosively. This explosive release can propel volcanic ash and pyroclastic flows into the atmosphere, creating a cloud that can reach heights of tens of kilometers. Consider the sheer volume of material involved. During an eruption, supervolcanoes can release thousands of cubic kilometers of volcanic material. This extraordinary quantity not only reshapes the landscape, but can also have far-reaching consequences on the climate. Ash and gases can linger in the atmosphere, leading to a phenomenon known as volcanic winter, where global temperatures drop due to the sunlight being blocked. Detection of these monumental events relies heavily on modern technology. Scientists monitor seismic activity and gas emissions to get a clearer picture of what lies beneath the surface. Seismographs, which measure vibrations in the ground, play a critical role in detecting the subtle movements of magma as it shifts and flows. A series of small earthquakes, often referred to as tectonic tremors, can indicate that magma is making its way towards the surface. These tremors may go unnoticed by the casual observer, yet they are the Earth's way of communicating impending change. In addition to seismic monitoring, gas emissions serve as another vital indicator. Gases such as sulfur dioxide and carbon dioxide can escape from the magma. An increase in these gases can signal that magma is nearing the surface. Researchers analyze these emissions using sophisticated equipment to assess their composition and concentration, providing crucial insights into the behavior of the supervolcano. Yet, what warning signs might we observe before an eruption occurs? Changes in land elevation, known as ground deformation, can provide vital clues. As magma accumulates and pressure builds, the ground can swell and bulge, creating noticeable changes in the landscape. Imagine a balloon gradually inflating. As the air fills it, the surface stretches and distorts. This phenomenon has been observed in various supervolcanoes, alerting scientists to the potential for an eruption. Another intriguing aspect is the thermal anomalies that can arise. As magma heats the surrounding rock and water, surface temperatures may increase. Hot springs and geysers might become more active, creating a spectacle of nature while simultaneously hinting at deeper geological processes at play. These signs are crucial pieces of the puzzle, helping researchers piece together the timeline of an impending eruption. To illustrate these concepts, we can turn to historical case studies that have shaped our understanding of supervolcanic activity. One of the most famous examples is the eruption of the Yellowstone supervolcano, which occurred approximately 640,000 years ago. This event released a staggering amount of ash and volcanic material, covering vast areas and leaving a lasting imprint on the landscape. Today, scientists continue to study Yellowstone, utilizing advanced monitoring techniques to keep a watchful eye on its behavior. Another notable case is the eruption of Toba, which took place around 74,000 years ago. It is believed to be one of the largest volcanic eruptions in history, leading to a dramatic cooling period that affected global climate. The aftermath of the Toba eruption is thought to have significantly impacted human populations, with some theories suggesting a bottleneck in human evolution. Such profound effects remind us of the power wielded by these geological giants. As we consider these past eruptions, we are reminded of the delicate balance between the Earth's internal forces and the surface world we inhabit. The interplay of magma, gas, and pressure shapes not only the landscape, but also the very conditions that support life. At times, it may feel like a dance of nature, where every movement echoes the potential for change and transformation. As we delve deeper into the science behind these eruptions, we realize that understanding supervolcanoes is not merely an academic exercise. It is a quest to comprehend our planet and the forces that govern it. Knowledge empowers us to predict and prepare for potential eruptions, safeguarding communities and ecosystems. The study of supervolcanoes is a testament to human curiosity and ingenuity. Scientists from diverse fields collaborate to unravel the mysteries of these colossal formations. Geologists, seismologists, and atmospheric scientists work in concert, sharing insights that shape our understanding of volcanic behavior and its implications for life on Earth. In contemplating the future of supervolcanoes, we must ask ourselves, how can we better prepare for these magnificent yet terrifying events? The answer lies in continued research and monitoring. By harnessing technology and fostering collaboration across disciplines, we can enhance our ability to detect and respond to the signs of an impending eruption. As we reflect on the magnificence of supervolcanoes and their eruptions, we gain a deeper appreciation for the Earth's dynamic nature. Each eruption tells a story of power, transformation, and resilience. It serves as a reminder of our planet's ever-changing landscape and the delicate balance that sustains life. The journey of understanding supervolcanoes is one that invites us to remain vigilant, curious, and engaged with the world around us. The intricate dance of geological forces continues beneath our feet, shaping the world in ways that often elude our immediate perception. As we probe further into the mechanisms of supervolcanoes, we discover that their eruptions are not merely random acts of nature. Each eruption is preceded by a series of signs, a symphony of geological activity that hints at the immense power brewing beneath the surface. In the realm of seismic activity, the patterns of earthquakes can serve as a precursor to an impending eruption. As magma forces its way upward, it creates stress in the surrounding rocks, leading to fractures and, ultimately, quakes. Imagine the quiet rumble of a distant train approaching. The tremors felt on the surface can be the Earth's way of signaling that something monumental is on the horizon. Researchers have observed that these seismic events often increase in frequency and intensity prior to an eruption, providing scientists with vital data to interpret and predict volcanic behavior. In addition to seismic monitoring, the release of gases, particularly sulfur dioxide and carbon dioxide, offers another layer of insight. These gases, which escape from the magma, can be measured at the surface. An uptick in gas emissions can indicate that magma is ascending, heating the surrounding rocks and prompting a response from the surface environment. Scientists have developed sophisticated instruments to measure these emissions, analyzing their chemical composition to glean information about the conditions deep within the Earth. This method allows researchers to create a clearer picture of the state of the magma and its potential for eruption. Ground deformation is another compelling sign that warns of an impending eruption. When magma accumulates in a chamber beneath the surface, it exerts pressure on the overlying rock layers. This pressure can cause the ground to swell or bulge, leading to noticeable changes in the landscape. Picture a gentle rise in the earth, like a slow exhale as the magma pushes outward. This phenomenon has been documented at several supervolcano sites, including Yellowstone, where ground deformation has been closely monitored for decades. Such observations are crucial for scientists as they provide real-time data on the dynamics of supervolcano behavior. The interplay of these warning signs underscores the complexity of predicting supervolcanic eruptions. It is not merely a matter of observing one indicator, but rather synthesizing multiple streams of data. The task often resembles piecing together a puzzle, where each piece, be it seismic data, gas emissions, or ground deformation, adds to the overall picture of what lies beneath. As we delve into historical eruptions, we can learn from the past to prepare for future events. The eruption of Lake Toba, for instance, serves as a profound reminder of the far-reaching consequences of supervolcanic activity. Spanning thousands of years, its aftermath created climatic shifts that affected ecosystems and human populations alike. The significance of Toba extends beyond its immediate impact. It highlights the interconnectedness of geological events and their effects on life. The eruption of the Campi Flegrei supervolcano in Italy is another case worth examining. This caldera, formed by explosive eruptions, has shown signs of unrest in recent years, prompting scientists to closely monitor its activity. Ground deformation and gas emissions have been observed, leading to increased scrutiny of its potential to erupt again. The lessons learned from Campi Flegrei remind us that the risks associated with supervolcanoes are not confined to distant history, but remain relevant today. As we reflect on these examples, we may wonder how we can enhance our understanding and preparedness for potential eruptions. The answer lies in the collaboration among scientists from various disciplines. Geologists, geophysicists, and atmospheric scientists must work in concert to share their expertise and insights. This collaborative spirit can lead to more effective detection methods and improved response strategies. The technological advancements in monitoring supervolcanoes have revolutionized our ability to predict eruptions. Remote sensing techniques, such as satellite imagery, allow scientists to observe changes in land surfaces and gas emissions over large areas. These technologies provide a bird's-eye view of volcanic systems, revealing shifts that may not be apparent from the ground. Imagine the power of seeing the Earth breathe and shift from above, gaining insights that ground-based observations alone cannot provide. In addition to these advancements, researchers are increasingly turning to machine learning and data analysis techniques to process vast amounts of seismic data. These tools can identify patterns and anomalies that may indicate changes in volcanic activity, allowing for more timely alerts. As the field evolves, the integration of diverse scientific approaches will be crucial in enhancing our capacity to respond to potential threats posed by supervolcanoes. The world of supervolcanology is not just a study of rocks and gases. It is a window into the dynamic processes that shape our planet. Each discovery brings us closer to understanding the forces at work beneath the surface. As scientists unveil the secrets of supervolcanoes, we are reminded that the Earth is a living entity, constantly evolving and transforming. In contemplating the future, we must ask ourselves how we can further bolster our preparedness for these geological giants. The answers lie in fostering a culture of awareness and education, not only among scientists, but also within communities that reside near supervolcanoes. Engaging the public in discussions about volcanic hazards can empower individuals to understand and respond to the risks associated with living in proximity to these powerful forces of nature. As we continue our journey through the world of supervolcanoes, we gain a deeper appreciation for the intricate web of interactions that shape our planet. Each eruption tells a tale of resilience and transformation, echoing through time as a reminder of the power of nature. The quest to understand supervolcanoes is an ongoing endeavor, urging us to remain vigilant, curious, and connected to the world around us. Chapter 3: Supervolcanoes and Climate Change: Global Consequences. When a supervolcano erupts, the immediate climate effects can be staggering, reverberating across the globe in ways that are both profound and unsettling. Imagine standing in a landscape transformed overnight, where the skies darken as ash clouds billow into the atmosphere, blocking sunlight. This phenomenon can lead to a dramatic and swift cooling of the Earth's surface. The ash and sulfur dioxide released during such an eruption can reflect solar radiation, creating a veil that alters weather patterns. The aftermath of a supervolcano's eruption can lead to what scientists call volcanic winter. This term evokes a chilling image of a world plunged into cold and darkness, where temperatures drop significantly for months or even years. The famous eruption of Mount Tambora in the early 19th century serves as a poignant example. It is often cited as the catalyst for the year without a summer, a time when crops failed across Europe and North America, leading to widespread famine. The ash thrown high into the atmosphere can linger for a long time, creating a ripple effect that influences global weather systems. As we consider these immediate effects, it's essential to delve into the long-term climatic shifts and their implications. Supervolcanic eruptions do not merely disrupt the climate for a season, they can alter it for decades. The intricate balance of ecosystems can shift dramatically in response to these changes. For instance, reduced sunlight can inhibit photosynthesis, leading to a decline in plant life, which in turn affects herbivores and the entire food web. Historically, several significant climate events have been linked to supervolcanic activity. The eruption of the Toba supervolcano in Indonesia, occurring around 75,000 years ago, is one of the most discussed events in this context. It is believed to have caused a global temperature drop, resulting in a volcanic winter that may have drastically reduced the human population. Some researchers suggest that this event could have pushed our ancestors to the brink of extinction. The echoes of these ancient eruptions remind us of the power these geological forces hold over our planet's climate. In examining the effects of supervolcanoes, it is intriguing to compare them with the impacts of human-induced climate change. While both phenomena can lead to significant alterations in temperature and weather patterns, the mechanisms and long-term consequences differ greatly. Human activity has gradually increased atmospheric carbon dioxide levels, contributing to the greenhouse effect and global warming. This slow but steady rise in temperatures contrasts sharply with the rapid cooling that can occur after a supervolcanic eruption. The difference in scale and speed of these changes is striking. Human-induced climate change unfolds over decades and centuries, whereas a supervolcanic eruption can unleash its effects within days. The urgency of addressing climate change is underscored by these differences. One might ask, how can we prepare for the abrupt changes that supervolcanoes can bring, especially when they can happen with little warning? Understanding the historical context is vital. The eruption of Krakatoa in the late 19th century exemplifies how a single explosive event can reshape climate patterns for years to come. The aftermath of Krakatoa saw global temperatures drop, and strange weather phenomena were reported, including vibrant sunsets and unusual atmospheric conditions. This eruption serves as a reminder of the interconnectedness of our climate system and the lasting impacts of geological events. Moreover, the implications of these eruptions extend beyond mere temperature changes. The release of volcanic gases can lead to acid rain, affecting freshwater sources and soil quality. These changes ripple through ecosystems, challenging species to adapt or face extinction. Consider the resilience of nature. After the Toba eruption, life eventually found a way to rebound, adapting to the new conditions. It raises the question, how adaptable are we as a species? Can we learn from the past to mitigate the effects of both natural and human-induced climate changes in the future? As we contemplate these connections, we can also reflect on the contributions of remarkable individuals in the field of volcanology. Scientists like John H. L. Allen, who studied the effects of volcanic eruptions on climate, have provided invaluable insights into the mechanisms at play. Their work has illuminated the pathways through which supervolcanoes can influence global weather and climate, creating a bridge between geological phenomena and human experience. The timeline of human history is interwoven with these extraordinary events. Our ancestors witnessed the dramatic changes wrought by supervolcanoes, shaping their lives and civilizations in ways that echo through time. The lessons learned from these historical episodes prompt us to consider our current trajectory. What if we could harness the knowledge of the past to navigate the challenges of our present? Understanding the climatic consequences of supervolcanoes can inspire us to take proactive steps in addressing the looming threat of climate change. As we draw parallels between natural and anthropogenic influences on the climate, it becomes increasingly evident that the Earth's geological processes are both magnificent and terrifying. The immense power of supervolcanoes serves as a reminder of nature's unpredictability, urging us to respect the delicate balance of our environment. In contemplating the future, one might wonder how we can prepare for the potential repercussions of supervolcanic eruptions. The reality is that, while we cannot predict when the next supervolcanic eruption will occur, we can study patterns and historical data to better understand possible outcomes. The concept of resilience emerges as a critical theme. How can societies build resilience to withstand the sudden shifts caused by supervolcanoes? Developing early warning systems, fostering environmental awareness, and investing in sustainable practices are all essential steps we can take to mitigate the impacts of both natural and human-induced climate changes. As we continue to explore the intricate relationship between supervolcanoes and climate, we recognize that the Earth is a living, breathing entity, constantly evolving and responding to the forces within it. Each eruption, each climatic shift, offers insights into the resilience of life and the potential for adaptation. In this vast narrative of our planet, supervolcanoes stand as monumental chapters, filled with lessons of power, destruction, and ultimately, rebirth. They remind us of our place within the larger tapestry of life and the importance of understanding the forces that shape our world. With this in mind, let us remain curious and vigilant, ready to learn from the past and prepare for the unpredictable future ahead. The immediate effects of a supervolcanic eruption are striking, yet the long-term climatic shifts that follow can be equally profound. Imagine a world where the consequences of a single eruption ripple through decades, altering weather patterns and ecosystems. These shifts can lead to a cascade of effects that reverberate through time, illustrating the delicate balance of our planet's climate. In the aftermath of an eruption, the atmospheric alterations often extend far beyond localized regions. the ash and gases released can encircle the Earth, creating a temporary shroud that diminishes sunlight. This phenomenon does not just cool the atmosphere, it can disrupt precipitation patterns, leading to droughts in some areas while causing excessive rainfall in others. Such changes can push ecosystems to their limits, forcing adaptations that may take generations to manifest. Consider the profound implications for agriculture. Crops that thrived under a stable climate could falter under shifting conditions. The balance of food production becomes precarious, especially in regions highly dependent on consistent weather patterns. Would humanity be prepared to adapt its agricultural practices to survive such drastic changes? The historical record provides insight, revealing how societies have grappled with these challenges in the past. The eruption of Mount Pinatubo in the early 90s serves as a contemporary example of how volcanic activity can influence climate. Following its eruption, global temperatures dropped significantly, demonstrating the immediate cooling effect of volcanic ash and sulfuric aerosols. The world witnessed a decline in average temperature for roughly 2 years, a stark reminder of nature's power to reshape our environment swiftly. Yet, the long-term consequences of supervolcanic eruptions are not merely transient shifts. They can lead to lasting climatic changes that reshape entire ecosystems. The interplay between volcanic activity and climate is a complex one, influenced by factors such as the volume of material released and the duration of the eruption. This relationship is vital for understanding historical climate events, particularly those linked to supervolcanic activity. One of the most significant historical events to consider is the eruption of Toba, which is believed to have triggered a volcanic winter lasting for years. The genetic bottleneck theory suggests that this event may have severely limited the human population. Imagine a world where our ancestors faced dwindling resources, struggling to adapt to a dramatically altered environment. This perspective prompts us to ponder the resilience of humanity in the face of environmental upheaval. The capacity for adaptation is a theme that echoes through the ages. Many species have displayed remarkable resilience, evolving to thrive in new conditions. The question we face today is whether we, as a species, can harness this same resilience in the face of a rapidly changing climate, both natural and anthropogenic. As we reflect on the historical context of supervolcanic eruptions, comparisons with human-induced climate change become increasingly relevant. While both can lead to significant alterations in temperature and weather patterns, human activity often introduces a gradual change, whereas supervolcanic eruptions produce abrupt and severe shifts. How do we reconcile this difference in timing and scale? Human-induced climate change unfolds over decades, with gradual increases in greenhouse gases leading to warming trends. In contrast, the aftermath of a supervolcanic eruption can plunge the Earth into a state of cooling almost overnight. This stark contrast challenges our ability to prepare for and respond to climate threats. The urgency of our current climate crisis is underscored by the rapidity of the changes brought about by supervolcanoes. Could we develop strategies to mitigate the impacts of both volcanic activity and anthropogenic climate change? The exploration of resilience becomes paramount as we seek to build adaptive capacities within our societies. In examining the historical climate events linked to supervolcanic activity, one must not overlook the contributions of those who have advanced our understanding of these phenomena. Scientists like Bill McGuire have illuminated the potential threats posed by supervolcanoes, emphasizing the need for preparedness. Their insights encourage us to consider not only the immediate consequences of eruptions, but also the long-term implications for global climate and ecosystems. As we consider the breadth of these impacts, it becomes clear that the interplay between supervolcanoes and climate is a dynamic one. The intricate dance of geological forces and atmospheric conditions shapes our world in ways that are both awe-inspiring and daunting. In contemplating the future, one might ask, how can we harness our knowledge of past eruptions to prepare for what lies ahead? By studying the patterns and consequences of supervolcanic activity, we can glean insights that may aid in our adaptation efforts. The prospect of a supervolcanic eruption serves as a reminder of the unpredictability of our planet. We must remain vigilant, understanding that the Earth is a complex system, one that requires our respect and careful stewardship. As we work to address the challenges of climate change, let us also remember the lessons of history, drawing from the resilience of both nature and humanity. This ongoing narrative of our planet invites us to reflect on our connection to the Earth. Each supervolcano, each climatic shift, enriches our understanding of the delicate balance of life and the forces that shape our existence. As we tread forward, let us do so with a sense of purpose and commitment to safeguarding our shared home, learning from the past as we forge a path into an uncertain future. Chapter 4: The Potential for Extinction, Supervolcanoes and Civilization. The threat of a supervolcanic eruption looms like a shadow over human civilization, a reminder of nature's raw power and unpredictability. Unlike typical volcanic events, which may disrupt a local community, a supervolcano can unleash an eruption so colossal that it alters the very fabric of life itself. As the ground shakes and roars, imagine the sheer force propelling volcanic ash and gases high into the atmosphere, creating an apocalyptic scene that feels both distant and imminent. What would happen if such a cataclysm were to occur? The scenarios for societal collapse following a supervolcanic eruption are as diverse as they are chilling. In the aftermath of an eruption, the thick plume of ash that blankets the landscape can collapse not only ecosystems, but entire agricultural systems. With crops unable to photosynthesize, starvation could become a grim reality for millions. The interconnectedness of a modern world, with its reliance on global supply chains, further compounds the issue. An eruption could disrupt trade routes, leaving nations isolated and vulnerable. Consider the story of the Minoan civilization on the island of Santorini, a society that thrived until a massive volcanic eruption around 3,000 years ago. The eruption, which is believed to have been one of the largest in recorded history, led to tsunamis and widespread destruction. It is speculated that this event contributed to the eventual decline of the Minoans, altering their way of life irrevocably. Could our own civilization face a similar fate? Reflecting on historical precedents, we find other civilizations that have felt the tremors of volcanic activity. The Roman Empire, for instance, experienced significant disruptions due to the eruption of Mount Vesuvius. While this event is well known for the destruction of Pompeii, it served as a stark reminder of how quickly prosperity can turn to despair. The ash that fell upon the cities, while preserving their ruins for future generations, also buried the hopes and dreams of countless lives. In more recent history, the eruption of Krakatoa in the late 19th century sent shockwaves through the world, both literally and metaphorically. The atmospheric effects altered weather patterns across oceans, leading to what is known as the Krakatoa effect, which caused dramatic temperature fluctuations and unusual weather events for years. Imagine waking up one morning to a sky painted in hues of red and orange, a haunting reminder of nature's fury. Would we, in our modern sophistication, be able to cope with such a significant shift? Modern society, despite its advancements, remains vulnerable to the whims of supervolcanoes. our population density in urban areas creates a precarious situation. Imagine a city where millions reside, entirely dependent on the systems that deliver food, water, and energy. An eruption could sever these lifelines, leaving populations stranded and searching for resources. The intricacies of our technological advancements, while impressive, also contribute to our fragility. Consider the potential impact of a supervolcano like Yellowstone, a site of both beauty and danger. The ground above this geologically active hotspot has been a vibrant canvas of geysers and hot springs, yet beneath it lies a vast reservoir of magma waiting to be unleashed. If an eruption were to occur, the ash fallout could blanket large portions of the United States, crippling infrastructure and leading to chaos. The very systems that support our daily lives, transportation, communication, and emergency services, could falter under the weight of ash and despair. In this context, we must ask ourselves, how prepared are we for such an eventuality? Emergency response systems, while refined, often struggle under the weight of large-scale disasters. The lessons from past eruptions illustrate a need for comprehensive planning and education on the risks posed by supervolcanoes. How do we build resilience in our communities? Perhaps it begins with knowledge, understanding the signs of an impending eruption and the steps to take in response. The interconnectedness of our global society, while a source of strength, can also be a double-edged sword. In a world where food and resources are often transported across vast distances, a supervolcano's eruption could bring about catastrophic shortages. The agricultural systems that rely on predictable weather patterns and fertile soil could be jeopardized. As crops wither beneath the ash, the specter of famine could loom large. Imagine the chaos that might ensue as people scramble to secure basic necessities. The psychological impact of such a disaster could ripple through communities, leading to distrust and unrest. Would we band together in solidarity, or would fear drive us apart? The human response to such crises has varied throughout history, revealing the complexities of our nature in times of desperation. As we ponder the consequences of a supervolcanic event, it's essential to recognize the resilience of the human spirit. Throughout history, civilizations have faced monumental challenges and emerged anew. The story of humanity is one of adaptation and survival. Yet, the question remains, how much resilience can we muster in the face of a force as formidable as a supervolcano? In examining our vulnerabilities, we must also consider the advancements we have made. Modern science has equipped us with tools to monitor volcanic activity, providing insight into the subtle signs that precede an eruption. Seismographs detect tremors, satellite imagery can capture ground deformation, and gas emissions can signal changes in the magma chamber. These technologies offer a glimmer of hope in our quest to understand and mitigate potential disasters. However, the challenge remains in communication and preparedness. The urgency of informing the public about the potential risks of supervolcanoes cannot be understated. How do we ensure that individuals and communities understand the gravity of these events? Education plays a crucial role in fostering awareness, empowering people to take action in preparation for the unknown. As we look to the future, the potential for extinction due to supervolcano eruptions serves as a reminder of our connection to the Earth. We live on a planet shaped by dynamic forces, and the Earth continues to evolve. The lessons of history remind us that while we may feel invincible in our technological pursuits, we are ultimately part of a much larger system. In this fragile balance, the question arises, what legacy will we leave for future generations? Will we learn to coexist with these magnificent yet terrifying geological wonders, or will we remain oblivious to the threats they pose? The potential for extinction is not merely a tale of doom. It is a call to action, an invitation to reflect on our place in the world and the choices we make. As the echoes of past eruptions reverberate through time, they beckon us to listen closely. The stories of civilizations lost to volcanic fury remind us of our vulnerability, yet also highlight our capacity for resilience. It is a delicate dance between destruction and rebirth, a cycle that has played out for millennia. The earth may shake and roar, but within that chaos lies the potential for renewal. In this moment of reflection, let us consider the beauty of the world around us. The landscapes shaped by volcanic activity, the fertile soils born from ash, and the ecosystems that thrive in the wake of devastation reveal a profound truth. Life finds a way. The narrative of supervolcanoes is not solely one of destruction, it is also one of transformation. As we continue to explore the depths of our understanding, the interplay between supervolcanoes and civilization invites us to engage with nature's power. In acknowledging our vulnerabilities, we can strive for a harmonious existence, one that respects the forces that shape our world while preparing for the uncertainties that lie ahead. The consequences of a supervolcanic eruption extend far beyond immediate destruction. They weave into the very fabric of human existence, challenging our notions of stability and security. Imagine a world where our routines are upended, where the air is thick with ash and the sun struggles to penetrate the haze. The psychological toll of such an event could be as profound as the physical devastation. History offers us sobering lessons. Consider the aftermath of the eruption of Mount Pinatubo. While it may not have reached the catastrophic scale of a supervolcano, its effects were felt globally, showcasing the interconnectedness of our world. The eruption led to a temporary cooling of the planet, illustrating how a single event can disrupt weather patterns and agricultural cycles. The ripple effect demonstrated that even distant eruptions can influence food supply and economic stability in regions far removed from the epicenter. What would it mean for our modern conveniences if a supervolcano like Toba, known for its colossal eruption around 75,000 years ago, were to awaken again? The sheer volume of ash it could unleash would blanket vast regions, creating a barrier to sunlight. The immediate consequences would be devastating, but the long-term ramifications could include a significant decline in global temperatures, leading to what some scientists have termed a volcanic winter. How would societies respond to such a drastic change in climate? As we contemplate these scenarios, it is crucial to recognize our vulnerabilities. The infrastructure that supports modern civilization, roads, bridges, power grids, could be rendered useless under layers of ash. Imagine a transportation network choked with debris, making it nearly impossible to deliver essential supplies. The reality is that logistics, which rely heavily on efficiency and predictability, would be thrown into chaos. How prepared are we for a world where access to basic necessities becomes a struggle? The psychological impact of resource scarcity is profound. With food and clean water in short supply, the potential for civil unrest grows. People may turn against one another in desperation, fracturing the very social contracts that bind communities together. As we reflect on this, we might ask ourselves, how would we respond in the face of adversity? Would we find strength in unity, or would fear drive us to division? Moreover, our reliance on technology presents another layer of vulnerability. In a world dominated by digital networks, the collapse of communication systems could lead to disarray. Imagine being unable to reach loved ones or access information during a crisis. The comfort of connectivity could be stripped away, leaving us isolated in our most desperate moments. The fragility of our digital age becomes painfully evident when we consider the potential impacts of a supervolcanic eruption. Yet, amid these harrowing possibilities, there is a glimmer of hope. The scientific community is continuously advancing our understanding of these natural phenomena. With each new discovery, we edge closer to improving our preparedness. Monitoring systems that detect seismic activity, gas emissions, and ground deformation can provide valuable insights. As we harness technology, the question emerges: how can we effectively communicate this knowledge to the broader public? Education and awareness are essential in building resilience. Imagine communities actively engaged in discussions about natural disasters, preparing emergency plans, and understanding the signs of volcanic activity. The more informed we are, the better equipped we become to face the unknown. In looking at our historical relationship with volcanoes, we find stories of resilience that inspire. The people of Iceland, living in the shadow of their active volcanoes, have adapted their lives around these powerful forces. They have developed systems to monitor volcanic activity and implement safety measures, showcasing human ingenuity in the face of nature's unpredictability. Their experience reminds us that adaptation is possible, and we too can learn to live in harmony with the forces that shape our world. As we reflect on the potential for extinction posed by supervolcanoes, we must also embrace our capacity for change. The Earth is a dynamic entity, and so are we. Our survival depends not only on understanding these geological wonders, but also on fostering a spirit of cooperation and preparedness. The narrative of humanity is one of adaptation, and perhaps in acknowledging our vulnerabilities, we can find the strength to overcome them. The looming threat of supervolcanoes serves as a clarion call to rethink our relationship with the natural world. It urges us to engage with science, to foster community resilience, and to nurture an appreciation for the delicate balance that sustains life. In doing so, we honor the lessons of the past while preparing for the challenges that lie ahead. The tales of civilizations lost to volcanic fury are not merely stories of despair. They are reminders of our interconnectedness with the planet and the responsibilities that come with it. As the Earth continues to shift and change, we stand at a crossroads. The choices we make today will shape the legacy we leave for future generations. Will we heed the warnings of our planet, or will we remain indifferent to the forces that threaten our existence? The potential for extinction is an ever-present reality, yet within that reality lies a profound opportunity for growth, understanding, and resilience. As we journey forward, let us carry the wisdom of our ancestors, who faced their own trials and tribulations. Their stories remind us that even in the face of overwhelming odds, hope can flourish. The potential for extinction is not merely a narrative of doom, but a testament to our tenacity and our ability to rise from the ashes of despair. Each day we awaken to the beauty of the world around us is a reminder that life, in all its forms, is a precious gift worth protecting. Chapter 5: Preparing for the Worst: Mitigation Strategies for Supervolcanoes. In the realm of supervolcanoes, the notion of preparedness is not just a precautionary measure. It is an essential strategy for safeguarding lives and minimizing catastrophic outcomes. As we stand on the precipice of understanding supervolcanic eruptions, we recognize the critical role that monitoring systems play in our ability to predict these monumental events. Current monitoring systems employ a sophisticated array of tools, including seismographs, GPS stations, and satellite imagery, creating a watchful eye over regions susceptible to volcanic activity. These instruments detect subtle changes in the Earth, such as ground deformation and gas emissions, which can signal the awakening of a dormant giant. Imagine the vast network of sensors capturing the whispers of the Earth, interpreting them as clues about the state of a supervolcano. Through continuous monitoring, scientists are able to assess the likelihood of an eruption and provide invaluable data that informs both local communities and governmental agencies. Yet, even with advanced technology, the unpredictable nature of supervolcanoes poses challenges. The effectiveness of these systems relies on timely interpretation of the data they collect. As noted by a prominent volcanologist, the science of volcano monitoring is not just about observing, it's about understanding the language of nature. Equipped with this knowledge, communities can better prepare for the worst. Community preparedness plans are crucial in fostering resilience against potential supervolcanic eruptions. Local governments, in collaboration with scientists, can develop comprehensive strategies that outline evacuation routes, emergency shelters, and communication plans. Imagine living in a town where every resident understands their role in a crisis, where drills and educational workshops transform fear into confidence. These plans must extend to all corners of the community, ensuring that even the most vulnerable populations are included. Education plays a pivotal role in these efforts. Public awareness campaigns can disseminate information about what to expect during an eruption, the signs of impending activity, and the necessary steps to take for safety. By fostering a culture of preparedness, communities can reduce panic and improve response times. Visualize a community center bustling with activity, where families gather to learn about volcanic hazards, engage in simulations, and share resources. Each conversation and every shared experience builds a collective strength that can withstand the tremors of uncertainty. Government policies and disaster response strategies also form the backbone of effective mitigation against supervolcanic threats. In regions near supervolcanoes, policymakers must prioritize the allocation of resources for monitoring, education, and infrastructure preparedness. This could include provisions for public transportation to facilitate evacuations and the establishment of communication networks capable of functioning in the aftermath of an eruption, when traditional systems may fail. Consider the importance of these strategies on a larger scale. The government's role extends beyond immediate response. It involves long-term planning to address the potential societal upheaval that could follow a supervolcanic eruption. By establishing partnerships with scientific communities, governments can ensure that the latest research informs their policies. A collaborative approach can yield innovative solutions to mitigate the risks posed by supervolcanoes, transforming a reactive framework into a proactive one. As we contemplate the potential consequences of an eruption, the significance of public education becomes increasingly clear. Knowledge is a formidable ally in the face of geological uncertainty. A well-informed populace can not only respond more effectively during a crisis, but can also advocate for policies that prioritize safety and preparedness. Imagine a world where citizens are empowered to engage in discussions about volcanic hazards, where their voices shape local and national policies. Moreover, educational efforts should not be limited to adults. Engaging children in discussions about supervolcanoes can instill a sense of responsibility and awareness from an early age. Schools can incorporate lessons on geology, volcanic activity, and emergency preparedness into their curricula, creating a generation that is not only knowledgeable but also equipped to handle the unexpected. Picture young learners huddled around a model volcano, their eyes wide with wonder as they explore the dynamics of eruptions, discussing what they would do in the event of an emergency. The integration of art and storytelling into public education can also enhance understanding and retention of vital information. Imagine a community theater producing a play about the life cycle of a supervolcano, weaving facts and narratives that resonate with audiences of all ages. Such creative approaches can foster a deeper connection to the subject matter, transforming abstract concepts into relatable experiences. In this landscape of preparedness, the collaboration between scientists, government officials, and communities becomes paramount. Each entity plays a unique role, contributing to a larger framework of safety and resilience. Scientists serve as the guardians of knowledge, translating complex data into actionable insights. Government officials translate these insights into policies that enhance public safety, while communities transform information into action, ensuring that every individual is prepared for the worst. As we consider the multifaceted strategies for mitigating the impact of supervolcanoes, it becomes evident that the task is not solely about preventing an eruption. It is about cultivating a culture of preparedness and resilience. This culture must be nurtured through ongoing education, community engagement, and robust governmental frameworks. By fostering a shared understanding of the potential risks and a unified commitment to preparedness, we can empower individuals and communities to face the challenges posed by supervolcanoes with courage and confidence. Ultimately, the journey towards effective mitigation is one of collaboration and continuous learning. Just as the geological forces that shape our planet are complex and multifaceted, so too are the systems we create to respond to them. The interplay of monitoring, community preparedness, government policy, and public education weaves a safety net that can catch us in times of crisis. Together, they form a bulwark against the unpredictable nature of supervolcanoes, a reminder that while we cannot control nature, we can prepare for its whims. In this dance of knowledge and awareness, we are reminded of the power of unity and foresight. Each step taken, each plan devised, brings us closer to a future where we stand not in fear of the looming shadow of supervolcanoes, but in readiness to face whatever may come. As we move forward, let us carry the lessons of the past with us, learning from those who came before and forging a path toward a safer tomorrow. The intricate tapestry of community preparedness extends into the very fabric of daily life, encouraging individuals to incorporate safety measures into their routines. Local workshops can empower residents with knowledge about the geological features that define their landscape, helping them understand the risks associated with living in a supervolcano's shadow. Imagine a neighborhood gathering where residents discuss not just the science behind volcanic eruptions, but share personal stories and experiences. These narratives create a sense of shared vulnerability and unity, reinforcing the idea that preparedness is not merely an individual responsibility, but a collective endeavor. The role of technology in enhancing community preparedness cannot be overstated. Mobile applications designed to provide real-time updates about seismic activity and potential evacuation routes can serve as vital lifelines during a crisis. Picture a scenario where a smartphone alert resonates through homes, delivering crucial information that guides families to safety. This technology not only informs but also reassures, fostering a sense of control amid chaos. In tandem with these technological advancements, community drills simulate the challenges posed by a supervolcanic eruption. Residents practice evacuation routes and emergency responses, transforming abstract concepts into tangible actions. These drills can be especially beneficial for schools, where students learn to remain calm and organized, reinforcing the idea that even in the face of uncertainty, there exists a pathway to safety. Governments play an essential role in supporting these community initiatives, crafting policies that enhance disaster preparedness and response strategies. The allocation of funds for infrastructure improvements, such as reinforcing roads and bridges that may be critical during an evacuation, reflects a proactive stance toward potential disasters. The establishment of emergency response centers equipped to handle the influx of displaced individuals provides a safety net for communities. Consider the broader implications of government policies in the context of supervolcanic eruptions. When policymakers prioritize open communication and transparency, they build trust with the public. Town hall meetings can become platforms for dialogue, where citizens voice their concerns and are informed about potential risks and response strategies. Such engagement fosters a sense of ownership and responsibility among community members, encouraging them to advocate for the resources they need to ensure their safety. As we reflect on the importance of preparedness, we must also consider the role of public education and awareness campaigns. Imagine a world where every citizen has access to comprehensive resources that explain the science behind supervolcanoes and the potential societal impacts of an eruption. Such knowledge can demystify the nature of these geological giants, transforming fear into understanding. Public awareness campaigns can take many forms, from informational pamphlets distributed at community centers to engaging social media campaigns that spark conversations about volcanic hazards. These initiatives can make science accessible, using relatable language and visuals that resonate with diverse audiences. By framing discussions around supervolcanoes within the context of everyday life, communities can foster a culture of preparedness that transcends generations. Educational institutions also have a critical role to play in this landscape. Schools can serve as a nucleus for learning, where students not only explore the geological aspects of supervolcanoes, but also engage in critical thinking about disaster management. Imagine classrooms buzzing with curiosity as students debate the implications of a supervolcanic eruption, considering both environmental and humanitarian aspects. This kind of education cultivates a sense of agency among young learners, preparing them to become informed citizens who can contribute to community resilience. In the spirit of collaboration, partnerships between scientific organizations and educational institutions can enhance the effectiveness of public awareness campaigns. Guest lectures from volcanologists and field trips to monitoring stations can provide students with first-hand experiences that ignite their passion for the sciences. The fusion of education and experiential learning creates a dynamic environment where curiosity becomes a catalyst for action. As we explore the depths of preparedness, the significance of addressing mental health cannot be overlooked. The anxiety surrounding the potential for a supervolcanic eruption can be overwhelming, leading to feelings of helplessness. Mental health resources must be integrated into community preparedness plans, offering support systems for individuals grappling with fear or uncertainty. Consider the impact of community support groups that provide safe spaces for individuals to share their concerns, strategies for coping, and collective resilience. In this interconnected web of preparedness, we find that the journey toward resilience is not solely about technology, policies, or education. It is about people coming together. Each voice, each story, contributes to a collective narrative of strength and courage. As we witness the collaborative efforts of scientists, government officials, educators, and community members, we are reminded that our greatest asset in the face of uncertainty is our ability to unite. The road ahead may be fraught with challenges, but by embracing a comprehensive approach to preparedness, we can create a future where communities not only survive but thrive in the aftermath of a supervolcanic eruption. This is not merely a task for the scientists or policymakers alone. It is a shared responsibility that calls for the involvement of every individual, every family, and every community. As we envision this future, let us remember that preparedness is a journey, one that requires ongoing commitment and adaptation. The lessons learned from past eruptions, the voices of those who have studied and experienced volcanic activity, and the resilience of communities can guide us as we forge ahead. Together, we can cultivate a culture of awareness and preparedness, transforming our relationship with nature from one of fear to one of respect and understanding. In doing so, we honor not only the power of supervolcanoes, but also the power of human connection and shared purpose. Chapter 6, Case Study, the Yellowstone Supervolcano. The Yellowstone caldera, one of the most remarkable geological features on our planet, has a rich and captivating history. Formed by a series of colossal eruptions over the last 2 million years, it now sits as a majestic reminder of the Earth's dynamic nature. Stretching across the states of Wyoming, Montana, and Idaho, this vast caldera is a natural wonder that draws millions of visitors each year. Imagine standing at its edge, gazing into the sprawling landscape, where geothermal features such as hot springs and geysers hint at the immense heat lurking beneath the surface. The beauty of this area belies the powerful forces at play, forces capable of reshaping the environment in an instant. The most significant eruptions in Yellowstone's history occurred approximately 2.1 million, 1.3 million, and 640,000 years ago, each leaving behind a caldera that now serves as a window into the Earth's molten heart. With each eruption, the landscape transformed, creating a complex interplay of ecosystems that flourished in the aftermath. The last major eruption was so immense that it expelled a volume of material that would fill the Grand Canyon many times over. This eruption shaped not only the land, but also the climate, influencing weather patterns and ecosystems far beyond its immediate vicinity. In recent years, the Yellowstone caldera has become a focal point for geologists and volcanologists. Continuous monitoring efforts have heightened our understanding of this geological marvel. Scientists utilize an array of instruments, from GPS stations to satellite imagery, to track minute changes in the ground and gas emissions. These tools capture the subtle movements of the Earth, alerting experts to potential shifts that could signal increased volcanic activity. As visitors walk through the park, they tread on a landscape that is alive, where the ground may be shifting imperceptibly beneath their feet, and the air may carry traces of gases that tell stories of the magma that lies just below. Recent geological activity has sparked interest and concern alike. While the caldera has shown signs of uplift and subsidence, these fluctuations are part of a natural cycle. The ground beneath Yellowstone is not static. It is a living system, responding to the pressures of magma accumulation and the release of gases. In a recent report, scientists noted, the movement of the ground is a reminder of the dynamic nature of Yellowstone. It is a system that is always in motion. As we consider this, we may wonder, how do these changes affect the likelihood of an eruption? Potential eruption scenarios at Yellowstone are a topic of much discussion and intrigue. Volcanologists have studied the patterns of past eruptions to model future possibilities. While predicting an eruption is fraught with uncertainty, experts can outline several likely scenarios. The most concerning possibility is a large-scale eruption, which could release vast amounts of ash and gases into the atmosphere. Imagine a scenario where the sky darkens with volcanic ash, obscuring the sun and altering climate patterns across the globe. The consequences of such an event would be far-reaching, affecting agriculture, water supplies, and even air travel. In the event of an eruption, the immediate vicinity would be transformed into a landscape of devastation. The powerful forces unleashed could lead to pyroclastic flows, avalanches of hot gas, and volcanic material that travel at incredible speeds. Such devastation would not be confined to Yellowstone. The ash cloud could drift thousands of miles, impacting air quality and climate. As we reflect on these possibilities, it becomes clear that the repercussions of a supervolcanic eruption extend far beyond the park boundaries. The notion of global impact raises critical questions about our preparedness. What steps are being taken to mitigate the effects of a potential eruption? Local and national preparedness initiatives play a pivotal role in addressing this threat. Agencies such as the United States Geological Survey and emergency management organizations collaborate to devise plans that ensure public safety. These plans include evacuation routes, public education campaigns, and coordination with local communities to develop response strategies. In the heart of Yellowstone, the National Park Service works tirelessly to balance conservation with preparedness. They educate visitors about the park's geothermal features, emphasizing both their beauty and volatility. Imagine walking through the park, listening to rangers explain the science behind the geysers, while also acknowledging the potential for change that lurks beneath. This duality is a reminder of the delicate balance between nature's splendor and its capacity for destruction. Preparedness initiatives also extend beyond immediate response efforts. Scientists and researchers are engaged in ongoing studies to better understand the caldera's behavior. By analyzing geological records and conducting experiments, they seek to improve eruption forecasting models. The goal is to provide timely and accurate information to local communities and policymakers, fostering a sense of security and resilience in the face of uncertainty. One remarkable aspect of Yellowstone's story is the collaborative effort among scientists, government agencies, and local communities. This partnership embodies the spirit of preparedness. It reflects a collective acknowledgement of the potential threats posed by supervolcanoes and a shared commitment to safeguarding lives. As we consider the future, it is essential to recognize that preparedness is not merely about responding to an eruption. It is about fostering a culture of awareness and resilience. The geological history of Yellowstone serves as a powerful reminder of the Earth's dynamic nature. It tells a tale of creation and destruction, of beauty and danger intertwined. The recent geological activity only underscores the importance of understanding this extraordinary system. As we reflect on the potential scenarios that could unfold, it becomes evident that we must remain vigilant and proactive. The balance between the awe-inspiring beauty of Yellowstone and the lurking threat of its supervolcano is a narrative that calls for continuous exploration and understanding. By embracing the science and fostering preparedness, we can navigate the uncertainties of our natural world, ensuring that we honor both the remarkable history of Yellowstone and the lessons it teaches us about living in harmony with nature's powerful forces. As we contemplate the future of Yellowstone, we are invited to imagine a world where knowledge and awareness guide our actions. The beauty of nature, coupled with our commitment to preparedness, allows us to appreciate the landscape while respecting its potential for change. The story of Yellowstone is not just one of geological forces. It is a testament to human resilience and our ability to respond to the challenges that lie ahead. The interplay between the scientific community and local populations enhances the overall resilience in the face of potential threats. Through education and outreach, scientists work diligently to communicate the complexities of supervolcanoes, allowing communities to grasp both the risks and the proactive measures they can take. Imagine a local school where children learn about the Yellowstone supervolcano, engaging in interactive lessons about geology and safety protocols. By fostering a shared understanding, we empower individuals to act decisively should the need arise. In addition to education, preparedness initiatives include the development of comprehensive emergency response plans. These plans often encompass various scenarios, from minor seismic activity to a full-scale eruption. Local authorities collaborate with national agencies to ensure that evacuation routes are clearly marked and accessible. Imagine a family, well-versed in the emergency procedures, ready to act swiftly if the ground beneath them begins to tremble. This preparedness instills a sense of security, transforming anxiety into proactive engagement. One of the most fascinating aspects of the Yellowstone supervolcano is the research surrounding its geothermal features. The geothermal activity in the park not only captivates tourists, but also provides invaluable insights into the caldera's behavior. Scientists study hot springs, fumaroles, and geysers, recognizing that these features are indicative of the volcanic processes occurring below. Consider the iconic Old Faithful geyser, a natural clock that erupts with remarkable regularity. Its predictability serves as a comforting reminder of the natural rhythms that exist even amidst potential chaos. Moreover, the unique ecosystems that thrive in the geothermal landscapes of Yellowstone illustrate nature's resilience. These ecosystems are often filled with extremophiles, organisms that have adapted to survive in extreme conditions. Imagine tiny microbes that flourish in boiling water, thriving where most life would falter. Studying these organisms not only enriches our understanding of biology, but also offers clues about life on other planets, where similar conditions may exist. The research conducted at Yellowstone has implications that reach far beyond its borders, connecting us to the broader cosmos. As we consider the various aspects of readiness and research, it is also essential to recognize the role of technology in enhancing our understanding of supervolcanoes. Remote sensing techniques, such as satellite imagery, allow scientists to monitor changes in the caldera over vast areas and extended periods. These technological advancements enable a more comprehensive view of geological activity, illuminating patterns that might otherwise go unnoticed. Imagine the awe-inspiring images captured from space, revealing the ever-shifting landscape of Yellowstone, a reminder that even from afar, the Earth's forces are at work. The community response to geological hazards is further enriched by integration with climate studies. The potential impacts of a supervolcanic eruption on climate patterns are profound, as discussed in earlier chapters. As scientists strive to understand these relationships, the findings can inform not only local preparedness, but also global climate strategies. For instance, recognizing the possibility of a sudden cooling event due to an eruption encourages policymakers to consider resilient strategies in the context of broader climate change discussions. What if the lessons learned from preparing for a supervolcano could be applied to mitigate other climate-related challenges? The interconnectedness of scientific research, community preparedness, and climate resilience presents a holistic approach to dealing with the uncertainties posed by supervolcanoes. It creates a narrative that emphasizes not only the potential dangers, but also the strengths of collaboration and knowledge sharing. This narrative is one of hope and empowerment, reminding us that while we must respect the power of nature, we also possess the capacity to adapt and respond effectively. As we delve deeper into the ongoing monitoring efforts at Yellowstone, it's worth noting the role of citizen scientists in this endeavor. Enthusiastic volunteers participate in data collection, contributing to the body of knowledge that helps scientists understand the region better. Imagine a group of dedicated individuals, armed with the tools of science, meticulously recording observations of natural phenomena. Their contributions, while seemingly small, weave into the larger fabric of scientific inquiry, showcasing that everyone can play a part in advancing our understanding of the natural world. In this evolving landscape of science and community engagement, the Yellowstone supervolcano stands as both a magnificent natural wonder and a formidable force of nature. Its story is one of constant change, a reminder that beneath the surface of serene beauty lies a world of dynamic processes. The historical significance of the caldera, coupled with our modern understanding of its potential impacts, urges us to remain vigilant and informed. As we reflect on the challenges posed by the Yellowstone supervolcano, we recognize that the journey towards preparedness is ongoing. Scientists, communities, and policymakers must unite in their efforts to build a resilient future. The lessons drawn from this extraordinary geological phenomenon serve to remind us that, like the Earth itself, we too must be adaptable, responsive, and ready to confront the uncertainties that lie ahead. While the looming presence of the supervolcano may evoke fear, it also inspires a commitment to knowledge, resilience, and collective action. In this delicate balance between awe and respect for nature's power, we find a call to action. Our understanding of Yellowstone and its potential threats is not merely an academic exercise. It is a vital part of our shared responsibility to safeguard our planet and its inhabitants. The threads of curiosity, preparation, and cooperation weave together, creating a fabric of awareness that empowers us to face the future with courage and resolve. Chapter 7: Cultural Perspectives, Supervolcanoes in Myth and Folklore. As we turn our gaze toward the cultural perspectives surrounding supervolcanoes, we find a rich tapestry woven from the threads of ancient myths and legends. Throughout history, humanity has been captivated by the powerful forces of nature, and supervolcanoes have inspired tales that echo through generations. In many cultures, these giants of the earth are often portrayed not merely as geological phenomena, but as manifestations of divine wrath or the fury of nature itself. Consider the ancient Greeks, who attributed the creation of volcanic islands to the god Hephaestus, the blacksmith of the gods. They believed that eruptions were the result of his labors in the forge, where the fires of creation and destruction intertwined. Similarly, in the folklore of the Native American tribes around the Yellowstone region, the supervolcano is woven into their creation stories. The Shoshone, for instance, viewed the geysers and hot springs as the breath of their ancestors, a connection to the spiritual world that remains palpable in the steam rising from the earth. Imagine standing in a landscape where the ground rumbles and shakes, the air thick with the scent of sulfur, and the skies darkening with ash. This is the backdrop of countless legends, where volcanic eruptions serve as a metaphor for upheaval and transformation. In the myths of Indonesia, the eruption of Krakatoa is not only a natural disaster, but a powerful reminder of the balance between creation and destruction. The island itself, once a thriving paradise, was reshaped by the violence of nature, leading to stories of rebirth and resilience in the aftermath. Cultural interpretations of volcanic eruptions often reflect deeper human emotions and societal values. When Mount Vesuvius erupted, burying the city of Pompeii, it left behind a haunting tableau that is still studied today. The stories of those who lived there, frozen in time, speak to our fears of sudden loss and the fragility of life. The eruption became a metaphor for the capriciousness of fate, a reminder that the forces of nature can change lives in an instant. This perspective resonates through works of art and literature, where the volcano becomes a symbol of both destruction and the enduring human spirit. As we delve into the role of supervolcanoes in shaping human history, we recognize their impact on civilizations far and wide. The eruption of the Toba supervolcano in Indonesia, for instance, is believed to have caused a dramatic drop in global temperatures, leading to a bottleneck in human evolution. This event, occurring approximately 70,000 years ago, may have drastically reduced the human population, influencing the trajectory of our species. Imagine how a single eruption could alter the course of history and human development. It is a striking reminder of our interconnectedness with the planet. The myths surrounding supervolcanoes are not merely relics of the past. They continue to inspire modern artistic expressions. Artists, writers, and filmmakers draw upon the awe-inspiring power of these geological giants, crafting narratives that explore themes of chaos and rebirth. The stunning visuals of erupting volcanoes serve as a backdrop for stories of human resilience, echoing the sentiments of ancient tales. In contemporary literature, one can find characters who grapple with the consequences of living in the shadow of such colossal forces, reflecting our ongoing relationship with nature. Visual art, too, captures the essence of supervolcanoes, often portraying them as both magnificent and terrifying. The vivid colors of molten lava contrasted against the dark ash clouds create a striking image that lingers in the mind. Artists may depict landscapes before and after an eruption, illustrating the stark transformation that occurs. One can almost feel the heat radiating from the canvas, a visceral reminder of the power contained within the earth. The role of supervolcanoes in shaping mythology and culture extends beyond mere stories. They are a lens through which we can explore our fears, hopes, and understanding of the natural world. Each eruption, each tale, weaves a connection between humanity and the earth, reminding us of our shared history and the delicate balance of existence. In examining these narratives, one cannot help but wonder how our modern understanding of geology and volcanology influences our interpretation of these myths. Do we view them through a scientific lens, appreciating the geological processes at play, or do we allow ourselves to be swept away by the wonder and mystery of the tales? Perhaps it is a blend of both that enriches our experience, allowing us to appreciate the beauty of storytelling while grounding ourselves in the reality of the natural world. As we continue to explore the cultural significance of supervolcanoes, it is essential to remember that the echoes of these ancient tales still resonate today. The legends remind us of the raw power of our planet and the enduring human spirit that seeks to find meaning amidst chaos. Each eruption serves as a stark reminder of the forces that shape our world and our lives, inviting us to reflect on our place within this intricate web of existence. The stories of supervolcanoes are not just relics of the past. They are vibrant threads that connect us to our ancestors and to one another. They remind us that, despite our advances in technology and understanding, we remain at the mercy of nature's whims. In embracing these narratives, we honor the wisdom of those who came before us, allowing their stories to guide us as we navigate our own relationship with the earth. As we reflect on the cultural interpretations of supervolcanoes, we can also consider the role of art and creativity in expressing our relationship with these formidable forces. Modern artists, inspired by the grandeur of supervolcanic landscapes, create works that evoke both beauty and terror. Through paint, sculpture, and digital media, they capture the essence of eruptions, transforming scientific phenomena into emotional experiences. Imagine walking through a gallery filled with vibrant depictions of volcanic landscapes, each piece inviting you to explore the depths of human emotion intertwined with the raw power of nature. Artists often utilize contrasting colors to convey the duality of destruction and creation, mirroring the very essence of supervolcanoes. The juxtaposition of fiery reds and deep blacks mirrors the turmoil of an eruption, while also hinting at the potential for rebirth in the aftermath. The stories told through art are not confined to canvas. They extend into the realm of film and literature, where directors and authors breathe life into the legends of these geological giants. Consider the cinematic portrayals of eruptions, where the screen fills with the chaos of ash clouds and flowing lava, inviting viewers to experience the visceral thrill of nature's fury. These modern interpretations echo the ancient tales, reminding us that the allure of supervolcanoes continues to captivate our imagination. As we draw closer to the heart of this chapter, we can find solace in the understanding that the stories surrounding supervolcanoes serve a purpose beyond mere entertainment. They connect us to the Earth and to each other, fostering a sense of empathy and awareness. In a world that often feels disconnected, these narratives remind us that we are part of something much larger, a shared experience shaped by the forces of nature. In contemplating the cultural significance of supervolcanoes, we uncover layers of meaning that resonate deeply with our collective human experience. They challenge us to confront our fears, to celebrate resilience, and to embrace the unknown. Each tale, each artistic expression, serves as a reminder of the delicate balance between humanity and the natural world, inviting us to reflect on our place within this vast and ever-changing landscape. As we continue this exploration, we are reminded of the importance of preserving these stories and the cultural heritage they represent. In a rapidly changing world, where the impact of human activity on the environment is more pronounced than ever, the lessons learned from our ancestors can guide us toward a more harmonious relationship with the Earth. Supervolcanoes, with their profound influence on both nature and culture, stand as symbols of this enduring connection. What will the next chapter of our story be? As we look to the future, let us carry these narratives with us, allowing them to shape our understanding of the world and inspire us to forge a path that honors both our heritage and the planet we call home. The tales that arise from the specter of supervolcanoes not only reflect humanity's struggle to understand the natural world, but also reveal a profound connection to the land itself. Many cultures have woven these geological giants into their narratives, interpreting their eruptions as divine messages or omens. In the folklore of the Maori people of New Zealand, for example, Mount Taranaki holds a special significance. This majestic peak, they believe, was once in love with the nearby mountain, Mount Egmont. The story tells of a great battle that ensued, leading to Taranaki's exile, a fate that echoes the tumultuous nature of volcanic eruptions. As these stories travel through generations, they serve as more than mere entertainment. They embody the experiences and fears of those who lived in the shadow of these powerful forces. The fear of eruptions translates into cautionary tales, as seen in the legends surrounding Mount Fuji in Japan. Revered as a sacred site, its eruptions were often interpreted as expressions of the gods' displeasure. Such beliefs can be seen as early attempts to make sense of the unpredictable nature of the world around them. In exploring the cultural interpretations of volcanic eruptions, we also see how these events have shaped the identity of communities. The eruption of Mount St. Helens in the early 80s, while not a supervolcano, profoundly impacted the Pacific Northwest. The ash that fell like snow transformed the landscape and altered the lives of those nearby. The stories of resilience that emerged in the wake of such destruction remind us that even in chaos, there is potential for renewal. Artists and poets have captured this duality, crafting works that reflect both the devastation and the rebirth that often follows such calamities. Consider the echoes of these narratives in modern artistic expressions. Contemporary artists take inspiration from the raw power of supervolcanoes, using their medium to evoke the awe and terror they inspire. Sculptors mold clay into forms that mimic the flowing lava, capturing its essence in tangible ways. Writers pen novels that delve into the lives of those who experienced volcanic eruptions, weaving together the threads of personal and collective histories. In film, directors frame the chaos of eruption scenes with breathtaking visuals, drawing audiences into the heart of the action. These portrayals not only entertain, but serve as a reminder of the ever-present power of nature. The visual and emotional impact of these works often leaves an indelible mark on our psyche, encouraging us to reflect on our relationship with the earth. As we embrace these artistic expressions, we find a common thread that connects the ancient stories to the modern world. They remind us that, despite our advancements and understandings, we are still vulnerable to the whims of nature. This vulnerability is beautifully encapsulated in the works of artists who channel their fears and hopes into their creations, reflecting the same sentiments expressed by those who lived centuries before them. Moreover, the narratives surrounding supervolcanoes serve as a reminder of our shared human experience. They challenge us to confront the uncertainties of life, urging us to appreciate the moments of calm amidst the chaos. Each story, each piece of art, invites us to consider our place within this grand narrative, highlighting the delicate balance between humanity and the natural world. In examining these cultural expressions, one might wonder, what do they reveal about our understanding of existence? Are we simply seeking to explain the unexplainable, or are we yearning for connection in a world that often feels fragmented? Perhaps it is both. The stories and artistic interpretations reflect our desire to find meaning amidst uncertainty, to connect with something greater than ourselves. As we explore the layers of meaning embedded in these myths and artistic expressions, we become aware of how they shape our collective consciousness. Supervolcanoes, in their monumental presence, remind us of the forces that have shaped our planet and our cultures. They stand as symbols of resilience, urging us to honor the lessons learned from the past while navigating the complexities of the present. Through these narratives, we are reminded that our relationship with the earth is a shared journey. Each tale of eruption, each stroke of an artist's brush, connects us to those who came before and to one another. As we reflect on the cultural significance of supervolcanoes, we find ourselves part of a larger story, a narrative that transcends time and place, inviting us to consider our role in the intricate web of existence. In a world that often feels disconnected, the legends and artistic expressions surrounding supervolcanoes serve as a bridge, linking us to our heritage and to the natural world. They encourage us to honor the wisdom of those who lived in harmony with the land, reminding us that our survival hinges on understanding and respecting the forces of nature. As we continue to explore these themes, we may find ourselves asking how we can carry forward these narratives in a way that resonates with future generations. How can we inspire a sense of stewardship for the earth, rooted in the lessons learned from both ancient myths and contemporary art? The answers may lie in our willingness to embrace the stories of supervolcanoes, allowing them to guide us toward a more harmonious existence with the planet we call home. Chapter 8: The Role of Technology in Monitoring Supervolcanoes. The world of geology has witnessed remarkable advancements in technology, particularly in the realm of monitoring supervolcanoes. As we delve into this captivating field, it becomes evident that the tools we employ to predict eruptions are not merely instruments. They are lifelines that connect us to the Earth's profound mysteries. Imagine the intricate dance of data and technology, where scientists harness the power of innovation to observe the seemingly invisible movements of our planet. In the journey of understanding supervolcanoes, the role of technology has evolved dramatically over the years. The introduction of sophisticated sensors has revolutionized eruption prediction. These sensors, strategically placed around supervolcanoes, can detect even the slightest shifts in ground movement or changes in gas emissions. The very essence of a supervolcano, resting beneath layers of rock, can now be monitored with an acute precision that was once unimaginable. This technological evolution allows researchers to gather real-time data, enhancing our understanding of the behaviors that precede a potential eruption. Consider the implications of this heightened awareness. With technology at our fingertips, we can begin to interpret the Earth's whispers. This capability is essential, for the dynamics of supervolcanoes are complex and multifaceted. The range of signals that scientists analyze includes seismic activity, ground deformation, and thermal anomalies. Each piece of data serves as a puzzle piece, contributing to a larger picture of volcanic activity. Imagine piecing together a beautiful mosaic, where every tile represents a unique aspect of the Earth's behavior. The interplay of these technologies grants us insight into the otherwise enigmatic processes of supervolcanic systems. Satellites and remote sensing technologies have become invaluable allies in monitoring volcanoes. The view from above offers a comprehensive perspective of the Earth's surface, revealing changes that might elude ground-based sensors. Satellites equipped with advanced imaging technology can capture thermal infrared data, allowing scientists to detect heat patterns that indicate changes in volcanic activity. Picture a celestial guardian, silently observing the planet from above, capturing images that unveil the hidden dynamics of supervolcanoes. Remote sensing doesn't stop at mere observation. It enables scientists to analyze vast areas efficiently. This capability is especially vital for supervolcanoes like Yellowstone, where the geological features are expansive. By employing remote sensing techniques, researchers can assess the state of the caldera, monitoring thermal emissions and ground deformation over time. The data collected provides a clearer picture of potential hazards, leading to improved risk assessments and preparedness strategies. In this age of information, the techniques for data collection and analysis have become increasingly sophisticated. The integration of machine learning and artificial intelligence into geological studies has transformed the way we interpret volcanic data. Imagine algorithms that can sift through mountains of information, identifying patterns and anomalies that a human eye might miss. This technological synergy empowers scientists to predict potential eruptions with greater accuracy and efficiency. Moreover, data collection methods have expanded beyond the surface. The use of drones equipped with sensors can gather data from hard-to-reach areas, providing insights that were previously unattainable. These flying observers navigate the rugged terrains of supervolcanoes, capturing data that enhances our understanding of the subterranean processes that fuel these geological giants. The ability to survey hazardous areas without putting human lives at risk is a significant leap forward in volcanic research. As we consider the trajectory of supervolcano research, it is essential to envision the future of technological innovations. The next generation of monitoring tools promises to deepen our understanding of these magnificent geological phenomena. Imagine the possibilities that lie ahead: enhanced satellite systems with improved imaging capabilities, sensors that can monitor multiple variables simultaneously, and even more sophisticated algorithms that learn and adapt over time. The quest for knowledge about supervolcanoes continues to drive innovation. Researchers are exploring the potential of integrating various data sources, creating a comprehensive network that provides a holistic view of volcanic systems. This interconnectedness holds the promise of early warning systems that could mitigate the risks associated with supervolcanic eruptions. In the realm of monitoring supervolcanoes, collaboration among scientists, engineers, and technology experts is paramount. The shared goal of safeguarding lives and understanding our planet's complexities unites diverse fields. Imagine a consortium of minds, each contributing their expertise to create an advanced monitoring network, a collective effort that reflects humanity's commitment to coexist with nature's powerful forces. As we look toward the horizon, the advancements in technology for monitoring supervolcanoes are not just about prediction. They embody a deeper understanding of our planet. They remind us of the delicate balance between human existence and the Earth's raw power. The more we learn, the more we appreciate the intricate systems that govern our world. This journey of exploration and discovery is not just a scientific endeavor. It is a testament to human curiosity and resilience. The tools we develop and the knowledge we gain serve as a bridge between our understanding of the past and our hopes for the future. Each advancement brings us one step closer to unlocking the secrets of the supervolcanoes, ensuring that we remain vigilant and prepared in the face of nature's might. The interplay of technology and geology continues to evolve, promising a future where we may not only predict eruptions, but also understand the myriad of factors that contribute to their occurrence. The landscape of supervolcano research is changing, and with it, our ability to safeguard ourselves and the environment around us. As we envision the future of supervolcano monitoring, our imagination can soar to the possibilities of what lies ahead. Innovations in technology will not only enhance our capabilities, but will also inspire a deeper connection to the Earth. The more we understand our planet's dynamics, the more we can appreciate the delicate balance that sustains life. The journey into the heart of supervolcanoes is far from over. It is an evolving narrative filled with promise, caution, and wonder. As we contemplate the future innovations in supervolcano research, it is essential to recognize the role of interdisciplinary collaboration. The intersection of geology, engineering, and technology fosters an environment ripe for groundbreaking discoveries. Imagine a space where geologists work alongside computer scientists and engineers, each bringing their unique expertise to the table. This merging of perspectives not only accelerates advancements in monitoring techniques, but also enriches our understanding of the complex systems at play beneath the Earth's crust. One promising avenue of exploration involves the integration of enhanced machine learning algorithms that can adapt as new data is collected. These algorithms can be trained to recognize subtle variations in volcanic behavior, potentially leading to breakthroughs in eruption prediction. The ability to analyze vast datasets in real time ensures that scientists remain one step ahead in their efforts to decipher the intricate language of supervolcanoes. Moreover, the potential application of augmented reality in geological surveys could provide a revolutionary method for visualizing subsurface structures. Imagine geologists equipped with augmented reality glasses, overlaying complex geological data onto the physical landscape before them. This immersive experience could bridge the gap between theoretical models and real-world observations, enhancing our understanding of the intricate dance of magma and rock layers. As we consider the vast expanses of supervolcanic systems, the incorporation of autonomous monitoring drones could further revolutionize our approaches. These drones, equipped with advanced sensors, could traverse the rugged terrain of supervolcanoes, collecting invaluable data from areas that are otherwise inaccessible. Picture a fleet of drones silently gliding over the calderas, capturing high-resolution images and thermal readings that enrich our understanding of geothermal activity. In parallel, the development of next-generation satellite technology promises to enhance our ability to monitor supervolcanoes from space. These satellites could be designed to capture multispectral imagery, revealing not only thermal anomalies, but also alterations in vegetation and land use patterns that may signal changes in volcanic activity. The detailed insights gained from such observations can serve as an early warning system, allowing communities and scientists to respond proactively to the potential threats posed by supervolcanoes. The advancement in computational power opens even more doors to innovation. Simulations that model the behavior of supervolcanoes under various scenarios will provide crucial insights. Imagine a virtual representation of a supervolcanic eruption, allowing scientists to visualize the interplay of gases, ash plumes, and magma flows. These simulations can help to predict the potential impact of an eruption on both the environment and human populations, guiding effective mitigation strategies. As we explore the future of supervolcano monitoring, community engagement and public awareness emerge as critical components of a comprehensive strategy. The more informed the public is about the risks associated with supervolcanoes, the more resilient communities can become. Educational programs that highlight the significance of monitoring efforts can foster a culture of preparedness. Envision town halls where scientists share their findings with local residents, transforming complex geological data into relatable narratives that empower individuals to take proactive measures. The integration of citizen science also holds promise for the future of supervolcano research. By harnessing the observations and insights of everyday people, researchers can gather data from a broader array of locations and perspectives. Imagine a network of enthusiasts equipped with simple monitoring devices, contributing their findings to a collective database. This grassroots approach not only enriches the scientific community, but also cultivates a sense of shared responsibility for understanding and managing the geological forces that shape our world. In this evolving landscape of technology and science, the narrative of supervolcano monitoring is one of hope and potential. Each innovation brings us closer to unraveling the mysteries that lie beneath the surface, equipping us with the tools necessary to navigate the complexities of our planet. As we stand on the brink of these advancements, we are reminded of the delicate balance between humanity and the forces of nature. The quest for knowledge is not merely academic. It is an essential journey that informs our relationship with the Earth and enhances our capacity for resilience. Through these collective efforts, we can aspire to create a future where the whispers of supervolcanoes are not shrouded in mystery, but are instead understood and anticipated. The synergy between technology and geology serves as a beacon of progress, illuminating the path toward a deeper understanding of our planet's inner workings. As we move forward, let us embrace the possibilities that lie ahead, nurturing our curiosity and commitment to coexist harmoniously with the powerful forces that shape our world. As we delve into the future of supervolcano research, we are met with a horizon filled with potential breakthroughs. One particularly exciting avenue involves the development of smart monitoring networks that utilize the Internet of Things. These interconnected devices can continuously relay data, creating an efficient and real-time overview of volcanic activity. Imagine a future where sensors embedded deep in the Earth communicate seamlessly with scientists, providing instant updates about pressure changes, or gas emissions. This network could lead to unprecedented levels of vigilance, allowing for timely reactions to any signs of unrest. Another promising innovation lies in the realm of geophysical modeling. Researchers are increasingly employing advanced simulations that replicate the conditions within a supervolcano. These models help in visualizing magma movement and pressure dynamics, offering insights into how eruptions might unfold. Picture a simulation that illustrates the intricate dance of molten rock beneath the crust, revealing pathways that magma might take during an eruption. Such tools empower scientists to predict not only when an eruption might occur, but also its potential magnitude and impact. The collaboration between various scientific disciplines will also play a crucial role in shaping the future of supervolcano research. The merging of geology with disciplines such as atmospheric science and climate modeling can lead to a more comprehensive understanding of the far-reaching effects of supervolcanic eruptions. Envision scientists from different fields coming together, each contributing their expertise to paint a more complete picture of the implications of a supereruption. This interdisciplinary approach can enhance our preparedness and response strategies, fostering resilience in communities at risk. In addition to technological advancements, the role of public engagement and education will be paramount. By fostering a culture of awareness around supervolcanoes, we can empower communities to understand the risks and the necessary precautions. Imagine schools incorporating geological education into their curricula, where children learn not only about the science of supervolcanoes, but also about the importance of monitoring and preparedness. This knowledge can cultivate a generation that is more equipped to face the challenges posed by natural disasters. As we reflect on the advancements in technology for monitoring supervolcanoes, we are reminded of the delicate interplay between humanity and nature. The tools we develop serve not merely to predict eruptions, but to enhance our relationship with the Earth. Each technological innovation is a testament to our commitment to understanding the forces that shape our world. The journey of exploration in this field is one that intertwines curiosity with responsibility. As we strive to coexist with the powerful geological phenomena that lie beneath our feet. The story of supervolcano monitoring is still being written, and with each chapter, we gain deeper insights into the complexities of our planet. The advancements on the horizon promise not only to enhance our predictive capabilities, but also to enrich our understanding of the intricate systems at play. As we continue to push the boundaries of what is possible, we remain steadfast in our pursuit of knowledge, driven by a collective desire to protect both ourselves and the environment we call home. Chapter 9: Ethical Considerations: The Dilemma of Supervolcano Management. The ethical implications surrounding supervolcano management present a complex and often contentious dilemma. On one hand, there exists a natural inclination to intervene, driven by the desire to protect lives and mitigate potential disasters. On the other hand, the question arises: should we allow nature to take its course, even when the stakes are so high? This tension between intervention and natural processes invites us to reflect on humanity's role in the world and our responsibilities towards the environment. Imagine standing at the edge of a caldera, witnessing the serene beauty of a dormant supervolcano. The landscape, shaped by ancient eruptions, is a reminder of nature's power and unpredictability. Yet, beneath this calm exterior lies the potential for destruction. Some scientists argue that proactive measures, such as engineering solutions to divert magma flows or creating barriers to contain ash clouds, could save lives. However, these interventions carry their own risks and ethical considerations. What if our attempts to control nature inadvertently trigger an eruption. The prospect of playing God with geological forces raises profound questions about the limits of human agency and the consequences of our actions. Balancing scientific research with public safety is another critical aspect of supervolcano management. While scientists strive to understand the intricacies of these massive systems, the data they gather is often fraught with uncertainty. The science of predicting eruptions is inherently complex, as discussed in earlier chapters. Monitoring networks provide invaluable insights, yet they cannot guarantee absolute accuracy. As a result, decision-makers face a delicate balancing act. How do we convey the potential risks to the public without inciting panic or undermining trust in scientific expertise? Consider the Yellowstone supervolcano, a focal point for monitoring and research. The sheer scale of its potential eruption raises questions about evacuations and emergency preparedness. What would happen if scientists raised alarms based on their predictions, only to find that the supervolcano remained dormant? Conversely, if they downplayed the risks and an eruption occurred, the consequences could be catastrophic. This duality highlights the ethical responsibility of scientists and officials to communicate effectively, ensuring that communities are informed and prepared while avoiding unnecessary fear. Global cooperation is essential in managing the risks associated with supervolcanoes. The interconnectedness of our world means that an eruption in one region can have far-reaching effects, impacting climate, agriculture, and economies worldwide. Imagine a world where scientists from different nations collaborate, pooling their resources and knowledge to develop comprehensive strategies for monitoring and risk management. This cooperative spirit is vital, as the challenges posed by supervolcanoes transcend national borders. The historical context of volcanic eruptions reminds us of the interconnectedness of human society. The eruption of Mount Tambora, which altered weather patterns and caused widespread famine, illustrates the profound impact that a single event can have on global systems. In light of such examples, fostering international dialogue and collaboration becomes imperative. Scientists, policymakers, and communities must work together to create frameworks that address supervolcano risks, while respecting the sovereignty and needs of different nations. An often overlooked aspect of supervolcano studies is the role of indigenous knowledge. Many indigenous communities have lived in proximity to supervolcanoes for generations, developing a deep understanding of the land and its rhythms. Their insights can provide invaluable context for modern scientific research. Imagine the wealth of knowledge that has been passed down through stories and traditions, detailing the historical eruptions and their impacts on the environment and communities. Incorporating indigenous perspectives into scientific studies not only enriches our understanding, but also fosters respect for cultural heritage. It invites a dialogue between science and tradition, allowing for a holistic approach to supervolcano management. Indigenous peoples often have a profound connection to the land, viewing it not merely as a resource, but as a living entity deserving of respect. In this light, the ethical considerations surrounding supervolcano management become intertwined with cultural values and the stewardship of the Earth. As we contemplate the ethical dimensions of supervolcano management, we find ourselves at a crossroads. The choices we make today will shape not only the future of our communities, but also the relationship we cultivate with our planet. Are we prepared to embrace a model of coexistence with nature, recognizing our role as caretakers rather than conquerors? The answers to these questions demand thoughtful reflection and a commitment to ethical principles that prioritize both human safety and the integrity of natural processes. In this ongoing dialogue, it becomes clear that addressing the ethical considerations of supervolcano management is not a task for scientists alone. It requires the engagement of communities, policymakers, and indigenous voices, each bringing unique perspectives and insights to the table. Together, we can forge a path forward that respects the complexity of these geological giants while ensuring the safety of the people who inhabit their shadows. As we continue to explore the implications of supervolcano management, we must remain vigilant in our pursuit of knowledge, understanding that the balance between intervention and respect for natural processes is delicate. The ethical dilemmas we face are not merely theoretical. They resonate with the lived experiences of those who call these regions home. How do we honor their voices while also preparing for the unforeseen? The answers lie within a collective commitment to ethical stewardship, a promise to safeguard the future while embracing the lessons of the past. In the end, the question of how we manage supervolcanoes is not just a scientific challenge, it is a reflection of our humanity. Our choices today will echo through generations, shaping not only the landscapes we inhabit, but also the legacy we leave behind. The path forward is uncharted, yet it is illuminated by the insights and wisdom of those who have come before us. As we stand at this crossroads, we are reminded of the inherent responsibility we bear, not only to ourselves, but also to the earth and its myriad wonders. In contemplating the ethical dimensions of supervolcano management, we are reminded that the stakes extend beyond mere scientific inquiry. As we consider the broader implications of our actions, we must acknowledge the responsibility we bear not only to ourselves, but also to the ecosystems and communities entwined with these geological giants. How do we weigh the potential benefits of intervention against the moral imperative to respect natural processes? This question is at the heart of ongoing debates within scientific and ethical circles. The ethical considerations of intervention are particularly pronounced when we examine the potential ecological impacts of our actions. For instance, while some may advocate for engineering solutions to manage supervolcanoes, we must consider the unintended consequences that such interventions could unleash on the local environment. The delicate balance of ecosystems, often shaped by millennia of natural selection, could be disrupted by human interference. Imagine a scenario where an attempt to divert magma flows inadvertently alters the hydrology of an area, affecting local flora and fauna. It prompts us to ask, can we truly predict the outcomes of our interventions, or are we stepping into a realm of uncertainty that may yield more harm than good? Moreover, the tension between scientific research and public safety is a reflection of our societal values and priorities. In a time where information is readily available, how do we ensure that the public is informed, yet not overwhelmed by the potential threats posed by supervolcanoes? The challenge lies in effectively communicating risk without instilling fear, fostering an environment where communities can engage with the science while remaining grounded in reality. Scientists must navigate this landscape thoughtfully, balancing transparency with sensitivity. The case of the Yellowstone supervolcano serves as a poignant reminder of this delicate balance. The ongoing research and monitoring efforts around Yellowstone are crucial, yet they must be accompanied by clear communication to the public. How do we ensure that communities living in the shadow of such a powerful geological feature feel both informed and empowered? It is essential to build trust through open dialogue and education, creating a shared understanding of the science while addressing the real anxieties that may arise. Global cooperation in supervolcano risk management is another critical avenue for addressing these ethical considerations. The interconnected nature of our world means that the impacts of a supervolcanic eruption can transcend borders, affecting climate, agriculture, and economies on a global scale. As we confront the potential for widespread disruption, the need for a unified response becomes ever more apparent. Imagine a world where nations work hand in hand, sharing data and resources to create a comprehensive framework for managing supervolcano risks. This collaborative spirit not only enhances our ability to respond to potential threats, but also fosters a sense of shared responsibility for the planet. The historical context of supervolcanic eruptions emphasizes the importance of global cooperation. The eruption of Mount Pinatubo in the early 90s serves as a stark reminder of how interconnected our global systems truly are. The ash and gases released by this eruption led to global cooling and disrupted weather patterns, illustrating that the consequences of such events know no borders. In light of this, fostering international dialogue and collaboration is imperative. Scientists, policymakers, and communities must come together to share knowledge and develop strategies that respect national sovereignty while addressing the shared risks we all face. In this global endeavor, the incorporation of indigenous knowledge into supervolcano studies stands out as a vital component. Indigenous communities often possess deep-rooted connections to the land, passed down through generations. Their insights into the historical behaviors of supervolcanoes can provide invaluable context for modern scientific research. Imagine the stories and traditions that speak of the land's rhythms, detailing the eruptions and their impacts on both the environment and human communities. This knowledge is not merely anecdotal. It embodies centuries of observation and understanding. Integrating indigenous perspectives into scientific studies can create a more comprehensive approach to supervolcano management. It fosters respect for cultural heritage and acknowledges the importance of diverse knowledge systems. Such collaboration not only enriches our understanding, but also honors the voices of those who have lived alongside these geological giants for millennia. By inviting indigenous communities into the conversation, we can cultivate a more holistic approach that respects both scientific inquiry and cultural values. As we continue to navigate the ethical considerations surrounding supervolcano management, we are reminded that our choices extend beyond the realm of science. They resonate with the lived experiences of communities, echoing through generations. How do we ensure that these voices are heard and respected? The answers lie in our collective commitment to ethical stewardship, recognizing that our actions today will have lasting impacts on future generations. The path forward is not without its challenges, yet it is illuminated by the insights and wisdom of those who have come before us. As we grapple with the complexities of supervolcano management, we must remain vigilant in our pursuit of knowledge while honoring the ethical principles that guide our actions. The interplay between intervention and respect for natural processes invites us to reflect on our role as caretakers of the Earth, urging us to forge a course that prioritizes safety, sustainability, and the integrity of the ecosystems we inhabit. Ultimately, the ethical considerations surrounding supervolcano management compel us to confront the fundamental questions of our existence. Are we prepared to embrace a model of coexistence with nature, recognizing our responsibilities not just to ourselves, but to the intricate web of life that surrounds us? The answers to these questions will shape not only the future of our communities, but also the legacy we leave for generations to come. As we stand at this crossroads, we are called to reflect deeply on the choices we make and the values that underpin them, paving the way for a more harmonious relationship with the natural world. Chapter 10: The future of supervolcano research and its importance. As we look toward the future of supervolcano research, we find ourselves on the cusp of exciting advancements that promise to deepen our understanding of these geological giants. Emerging trends in research and monitoring are reshaping the landscape of volcanic science, paving the way for more effective predictions and a greater appreciation of the risks that supervolcanoes pose. Picture a world where scientists, equipped with cutting-edge technologies, can continuously observe the intricate dance of magma beneath the Earth's crust, translating its subtle movements into actionable insights for communities at risk. One of the most promising developments in this field is the advent of predictive modeling and simulations. These tools are rapidly evolving, allowing researchers to create sophisticated scenarios that consider a multitude of factors influencing supervolcanic behavior. Imagine being able to visualize an eruption's potential path, the spread of ash clouds, and the subsequent impact on climate and ecosystems. Advanced computational models simulate different eruption scenarios, providing invaluable data that can inform emergency preparedness plans. Through these simulations, scientists can answer vital questions. How far could ash travel? What areas would be most affected? Such knowledge is not merely academic. It holds the power to save lives and reduce the socioeconomic upheaval that could follow a supervolcanic event. The integration of interdisciplinary approaches is also becoming increasingly important in the study of supervolcanoes. Geologists, climatologists, ecologists, and even social scientists are coming together to form a holistic understanding of these complex systems. This collaboration acknowledges that supervolcanoes do not exist in isolation. Their eruptions have far-reaching consequences that touch on various aspects of life. For instance, consider how climate scientists work alongside volcanologists to understand the long-term climatic shifts that follow an eruption. The interplay between volcanic activity and climate change is a topic of growing concern, as the release of ash and gases can lead to significant alterations in global temperatures, demonstrating how interconnected our world truly is. Esteemed volcanologists have long echoed the sentiment that understanding supervolcanoes requires more than just geological expertise. It calls for a broad perspective that incorporates various scientific disciplines. As one prominent figure in the field put it, the future of volcanology lies in embracing complexity. By fostering an environment where different fields converge, researchers can develop a more comprehensive understanding of the processes at play, ultimately enhancing their predictive capabilities. As we contemplate the future of supervolcano research, it is essential to acknowledge the need for continued vigilance and investment in scientific inquiry. The lessons of history remind us that supervolcanoes have the potential to reshape civilizations. The catastrophic eruptions of the past highlight the importance of ongoing monitoring and research. Imagine the lessons learned from the eruption of the Toba supervolcano, which occurred approximately 75,000 years ago, leading to a dramatic bottleneck in human population. Such events underscore the necessity of dedicating resources to understanding these geological phenomena and reinforcing our preparedness for potential future eruptions. The advancements in technology provide a beacon of hope in this endeavor. Remote sensing technologies, including satellite imagery and drones, are revolutionizing how we observe supervolcanoes. These innovations allow scientists to gather critical data on ground deformation, thermal anomalies, and gas emissions, painting a clearer picture of a supervolcano's health. Imagine a network of satellites orbiting the Earth, each equipped with sensors that can detect minute changes in the landscape below. This comprehensive monitoring system can provide real-time data, making it possible for researchers to assess volcanic activity with unprecedented accuracy. Additionally, as artificial intelligence continues to evolve, its application in analyzing vast datasets offers new possibilities for predicting eruptions. Machine learning algorithms can sift through years of historical data, identifying patterns that may not be immediately apparent to human researchers. The potential for AI to assist in forecasting volcanic behavior heralds a new era in supervolcano research, where the combination of human intuition and machine efficiency leads to enhanced prediction models. However, as we embrace these technological advancements, we must also remain grounded in the ethical considerations that accompany them. The quest for knowledge should be balanced with a sense of responsibility towards the communities that could be affected by supervolcanic activity. Continuous engagement with stakeholders, including local populations and policymakers, is essential. How do we ensure that the fruits of research benefit those who may one day face the consequences of a supervolcano's awakening? The answer lies in fostering open dialogue and creating frameworks that encourage community involvement in preparedness and response strategies. The importance of supervolcano research extends beyond the immediate scientific community. It resonates with global implications, reminding us of our interconnectedness as inhabitants of this planet. The potential impacts of a supervolcanic eruption can ripple through economies, ecosystems, and societies, making it imperative for nations to collaborate in understanding and mitigating these risks. Imagine a world where countries come together, sharing data and resources, united in their commitment to safeguard lives and preserve the delicate balance of nature. In reflecting on the future of supervolcano research, we are reminded that vigilance is not merely a practice, it is a mindset. The Earth is a dynamic entity, and its supervolcanoes serve as a reminder of the forces that shape our existence. As we stand at the crossroads of advancing technology and deepening scientific understanding, we are called to approach these giants with respect and caution. The landscape of supervolcano research is evolving, and with it comes the responsibility to harness knowledge for the greater good. The tapestry of research, technology, and ethical considerations weaves a narrative that emphasizes the importance of continued inquiry into supervolcanoes. The future holds promise, but it also demands our attention and commitment. As we imagine the possibilities that lie ahead, we must remain steadfast in our dedication to understanding these remarkable geological phenomena. The path forward is one of collaboration, innovation, and a profound respect for the forces that lie beneath our feet, waiting silently for their moment to speak. As we embrace the future of supervolcano research, new methodologies are emerging that promise to enhance our understanding of these colossal systems. One such trend is the growing emphasis on real-time data integration. Researchers are increasingly turning to a combination of ground-based observations and satellite data to create a comprehensive view of volcanic activity. Imagine a scenario where scientists can correlate ground movements detected by seismographs with thermal imaging from space, providing a multi-layered perspective of a supervolcano's behavior. This synergy of data not only improves the quality of information, but also enables scientists to respond more swiftly to any signs of unrest. Moreover, the potential for citizen science is becoming an integral part of supervolcano monitoring. Technological advancements have made it possible for everyday individuals to contribute to research efforts. By utilizing smartphones and other devices, citizens can report observations of ground deformation, unusual smells, or changes in local wildlife behavior. This grassroots involvement empowers communities living near supervolcanoes, fostering a sense of agency in the face of natural hazards. The question arises: how can we harness the collective power of informed citizens to enhance our monitoring efforts? The answer lies in education and outreach, creating a culture of awareness around the risks associated with supervolcanoes. In tandem with these advancements, predictive modeling is reaching new heights. Researchers are developing increasingly sophisticated algorithms that can simulate the potential impacts of an eruption based on various scenarios. What if a supervolcano erupts during a time of climate change? How would that influence global weather patterns? By inputting different variables into these models, scientists can explore a multitude of what-if scenarios. This predictive capability provides critical insights for governments and emergency planners, allowing them to prepare more effectively for potential disasters. The importance of interdisciplinary approaches cannot be overstated in this context. The integration of social science perspectives into volcanic research is crucial for understanding how communities respond to the potential threat of supervolcanoes. How do cultural beliefs and historical experiences shape a community's perception of risk? Researchers like Dr. Kayla Smith have highlighted the significance of incorporating local knowledge and cultural narratives into disaster preparedness plans. By acknowledging the unique relationship that communities have with the land, scientists can create more effective and culturally sensitive strategies for risk communication and management. As we think about the future, we must also consider the role of climate change in shaping the behavior of supervolcanoes. The interconnectedness of geological and environmental systems is becoming increasingly clear. For instance, rising global temperatures can influence the hydrology of volcanic regions, potentially altering the dynamics of magma movement. Could the warming of the Earth lead to more frequent volcanic unrest? This crucial question underscores the need for collaborative research across disciplines, ensuring that we remain vigilant in our understanding of how these forces interact. The historical context of supervolcanoes provides valuable lessons for contemporary research. The eruption of Mount Tambora in the early 19th century serves as a stark reminder of the far-reaching consequences of volcanic activity. The subsequent year without a summer illustrates how a single eruption can disrupt global food supplies and climate patterns. How do we learn from these historical events to inform our future preparedness? By studying past eruptions and their societal impacts, we can better anticipate and mitigate the effects of future supervolcano activity. The importance of continued vigilance in supervolcano research cannot be emphasized enough. As we stand on the threshold of new discoveries, we must be proactive in our approach to understanding these geological behemoths. The lessons of history remind us that complacency can lead to dire consequences. A commitment to ongoing research and monitoring will ensure that we are equipped to face the challenges posed by supervolcanoes. Investing in supervolcano research is not merely a scientific endeavor, it is a societal imperative. The potential risks associated with these eruptions extend beyond the immediate vicinity of a supervolcano, affecting global systems and economies. As such, collaboration among nations becomes paramount. Imagine a world where countries share data, resources, and expertise to build resilience against supervolcanic threats. This cooperative spirit can foster a sense of unity in addressing challenges that transcend borders. In our pursuit of knowledge about supervolcanoes, we must also remain attuned to the ethical dimensions of our work. The implications of scientific advancements extend into the realm of social responsibility. How do we ensure that the benefits of our research reach the communities most at risk? Ethical considerations should guide our research agendas, ensuring that we prioritize the well-being of those living in the shadow of supervolcanoes. Engaging with local populations and incorporating their insights into research initiatives creates a more inclusive and effective approach to disaster preparedness. As we ponder the future of supervolcano research, we find ourselves at a pivotal moment. The convergence of technology, interdisciplinary collaboration, and community involvement presents a unique opportunity to enhance our understanding of these geological giants. Yet, with this opportunity comes responsibility. We must approach our work with humility and respect, recognizing that the forces we study are both awe-inspiring and potentially catastrophic. The journey toward unlocking the mysteries of supervolcanoes is one that requires patience, curiosity, and dedication. As we look ahead, let us embrace the challenges and possibilities that lie before us. The landscape of supervolcano research is continually evolving, and our commitment to understanding these phenomena will shape the world we inhabit for generations to come. The future is not merely a series of unknowns. It is a canvas upon which we can paint a more informed and prepared society, ready to face whatever the Earth may unveil.